Look at your car windshield right now. Every window except that front glass is probably tinted, a dark film baked onto the glass to block sun, heat, and prying eyes. It is a $100 aftermarket job most drivers get within a month of buying a new car. It has not changed in 50 years, a thin sheet of dyed plastic film pressed onto glass by hand in a garage. But right now, in a materials lab outside Hefei, Chinese engineers have built something that makes that entire film obsolete. It is glass that tints itself. No film, no installer, no fixed shade you are stuck with forever. You press a button, and in under a second, the glass itself turns from completely clear to nearly opaque black, then back again on command. If you are enjoying videos like this, please hit the like button because it takes a lot of effort to make these, and subscribe so you do not miss the next one. This is not a concept car gimmick locked inside a trade show booth. It is real, mass-producible smart glass, and it is about to make the entire aftermarket tinting industry disappear. How do you make a sheet of solid glass change color instantly, without any film, any spray, or any physical filter? It sounds like something out of a spy movie, but the physics are surprisingly well understood, just brutally hard to manufacture at scale. The technology is called electrochromic glass. Sandwiched inside the glass itself are several microscopically thin layers, an electrically conductive coating, an ion storage layer, and a special material called tungsten oxide. Here is the trick. Tungsten oxide is naturally transparent, but its molecular structure changes the instant an electrical charge passes through it. When you apply a small voltage, charged particles called ions migrate into the tungsten oxide layer, and the material's crystal structure physically shifts, absorbing light instead of letting it pass through. Reverse the voltage, and the ions migrate back out, and the glass returns to clear. Think about how a black and white photograph develops in a dark room, where a chemical reaction physically darkens the paper based on light exposure. Electrochromic glass does something similar, except the trigger is not light. It is electricity, and it is completely reversible in real time. The challenge was never really understanding this reaction. Scientists have known about electrochromic materials since the 1960s. The real problem was manufacturing tungsten oxide layers thin and uniform enough to coat an entire car window or building facade without cracking, clouding, or degrading after a few thousand charge cycles. That manufacturing problem is exactly what Chinese materials science labs have now cracked. And it is a much bigger deal than a fancy car window. To understand how significant this actually is, you need to go back to a much more humbling period in Chinese glass manufacturing. As recently as the early 2010s, China was the largest producer of raw flat glass on the planet by sheer volume, yet it could barely compete in the high-precision coated glass market. Advanced architectural glass, the kind used in skyscrapers to control heat and light, along with any specialty automotive glass requiring precise multi-layer coatings, came almost entirely from German, Japanese, and American manufacturers like Saint-Gobain, AGC, and Corning. Chinese factories could melt and cut glass by the ton, but the vacuum deposition technology required to lay down microscopically even coatings, layers sometimes just a few atoms thick, was a closely guarded Western specialty. State-run industrial reports at the time openly acknowledged the gap. China could produce the raw material in staggering quantities, but remained dependent on foreign firms for the thin film coating processes that actually made glass valuable. For a country trying to dominate global construction and automotive supply chains, this was an infuriating bottleneck. Skyscrapers across booming Chinese cities were being built with imported coated glass shipped in at a massive premium, despite sitting on the world's largest raw glass production capacity. Beijing responded the way it always does when it identifies a strategic weak point. It funneled state research funding directly into thin film deposition and smart materials science, treating electrochromic glass specifically as a target category because it combined two goals at once: architectural energy efficiency and automotive technology leadership. For nearly a decade, Chinese state labs and companies like Hefei's New Vision Optoelectronic ran endless trials, refining the vacuum coating process to lay down tungsten oxide layers with the uniformity needed to survive tens of thousands of tint cycles without degrading. Early prototypes clouded unevenly or wore out after a few hundred uses, useless for anything but a museum display case. By grinding through failure after failure, they eventually solved the durability problem, and smart glass moved from a laboratory curiosity into something you can now actually order for a car windshield. This is where the story stops being about window tint and starts being a direct threat to a surprisingly large chunk of American automotive commerce. The aftermarket auto tinting industry in the United States is a multi-billion-dollar business built entirely on a simple, permanent product. You choose a shade, an installer applies a physical film, and you are stuck with that exact darkness for the life of the car, regardless of whether you are driving through blinding desert sun or a pitch-black parking garage at night. Every major city has dozens of small tint shops surviving entirely on this one-time, fixed shade transaction. Self-tinting electrochromic glass eliminates the entire premise. Why would a driver pay to have a static film installed, one that can crack, bubble, and peel within a few years, when the factory-installed glass itself can shift from fully clear to nearly black on demand, adjusting automatically to sun angle throughout the day and reverting to fully transparent at night for visibility and safety? This is not a hypothetical threat sitting a decade in the future. Automakers already understand exactly how disruptive this is. Mercedes, along with several Chinese EV manufacturers, have already begun piloting electrochromic glass roofs and windows in production and near-production vehicles. Once the manufacturing cost drops far enough, and Chinese state-subsidized production is specifically engineered to crash that cost, factory-integrated smart glass stops being a luxury option and becomes a baseline expectation, exactly the way power windows and keyless entry did decades earlier. The moment that happens, the aftermarket tint shop, along with every mid-tier tint film manufacturer supplying it, faces the same fate as the corner video rental store the week Netflix went nationwide. This is exactly why American automakers and glass manufacturers are watching Chinese smart glass production with real unease, because the implications reach far beyond a slightly nicer window feature. Whoever controls the manufacturing base for electrochromic glass is not just selling a car accessory. They are positioning themselves to dominate an entirely new category of architectural and automotive glass that extends into commercial buildings, aircraft, and eventually consumer electronics. Boeing already uses a primitive version of this exact technology in the dimmable windows of the 787 Dreamliner, glass that darkens on demand instead of relying on a physical pull-down shade. If Chinese manufacturers can produce electrochromic glass at automotive scale cost, that same capability extends directly into commercial skyscraper windows, capable of automatically tinting to cut air conditioning costs across an entire building without a single physical blind. The American architectural glass industry, dominated by companies that have held their position for decades, suddenly faces a foreign competitor that can undercut them on both raw glass volume and now the high-margin smart coating that makes glass genuinely valuable. This mirrors the exact same pattern that played out in solar panels and electric vehicle batteries, where American and European firms held early technical leads, only to watch Chinese state-backed manufacturing scale up production so aggressively that unit costs collapsed, and Western firms could no longer compete on price. If that same playbook repeats in smart glass, an entire category of specialty American and German glass manufacturing faces the same kind of margin collapse that already hollowed out domestic solar panel production. There is also a less obvious layer to this shift that has nothing to do with manufacturing cost at all. Electrochromic glass is not just a passive material. It is an electrically networked component. To adjust automatically based on sun position, time of day, or a passenger's preference, the glass has to be connected to sensors and, increasingly, to the vehicle's onboard software system. That means the window itself becomes another networked node capable of being controlled, monitored, and potentially updated remotely. In a car, that raises the same quiet unease that has already surrounded Chinese-made connected vehicle components and infotainment systems. A physical part of the car that is not just glass anymore, but a piece of software-controlled hardware manufactured by a foreign supplier. American regulators have already flagged concerns over Chinese-made connected components inside vehicles sold domestically, restricting certain software and hardware from Chinese suppliers in vehicles built for the U.S. market. Smart glass complicates that picture further, because unlike an infotainment screen, nobody thinks to ask what a window is connected to. Despite the clear cost and convenience advantage, the psychological barrier holding back mass adoption in America may simply be a distrust of glass that behaves like a screen. Consumers have spent generations treating a car window as a fixed, dumb piece of safety glass. Something you roll down, not something that thinks. Asking someone to trust that their windshield will correctly clear itself in a sudden nighttime emergency, rather than getting stuck in a dark setting due to a software glitch or electrical failure, requires real confidence in the underlying technology. That hesitation is exactly why this rollout follows the same predictable path other Chinese hardware disruptions have taken. It starts in commercial and luxury applications first, premium electric vehicles where the smart glass becomes a flashy showroom feature, and high-end architectural projects eager to advertise energy efficiency. From there, it moves into mainstream new vehicle production as manufacturing costs fall, exactly the way backup cameras and lane assist sensors went from luxury options to mandatory standard equipment within a single decade. Eventually, it lands in the used aftermarket and retrofit space, quietly finishing off the traditional tint shop business entirely. Which brings us back to that stack of window tint rolls sitting in the back room of your local auto shop. For decades, fixed, permanent shade, and living with that decision for the life of the car. That entire premise is now negotiable. Glass can think. It can react instantly to a blazing sun or a dark tunnel without a single physical film ever touching it. The tint shop, the peeling film, the fixed shade you regretted a year after installing it. All of it starts to look like the manual crank window the moment the electric version became standard. A relic nobody misses once the better version arrives. But before you get too excited about never scheduling a tint appointment again, remember that the same networked glass that reacts automatically to light is also, by definition, connected to a system capable of being monitored or controlled remotely. We are trading a simple, dumb piece of privacy film for a smart, connected material whose behavior depends entirely on software and firmware built by someone else. The company or country that masters this manufacturing process is not just selling a nicer car window. They are quietly building the next standard component for how buildings and vehicles manage light, heat, and privacy for decades to come. So here is a question for you. If your next car came standard with glass that tints itself instantly at the push of a button, would you welcome never paying for aftermarket tint again? Or does the idea of window glass connected to a computer system make you trust the simple, dumb film more? Let me know your honest answer down in the comments.